Hello all. For any embedded application, power consumption is a very important factor, especially in the IoT applications where the products run on batteries. Ultimately, the chips or basically the RF transceivers which provide the wireless functionality should consume as much low power as possible. Basically, power consumption we can say is the unique selling point of that particular chip. So, more the power consumed, very less chance that we do select that particular chip in the application, whereas we do try to select a chip which has lowest power consumption. Now, generally when we see chips have different states, like example when it is running in its full throttle, or basically when it is doing its normal operation, we generally call it the active state. Apart from active state, sometimes we might put it in different states where some of the peripherals might be disabled to ensure that unnecessary power is not drawn. Like example, let us assume we are not using one of the interface. Okay, we do power down that particular interface to ensure that power is not consumed. So for any chip, there are specific power states that are being defined. For 917 as well, there are several power states which are mentioned in their datasheet, which we call active state, standby state, deep sleep state, and off state. Off state means it's a completely shutdown state. Okay, so these are the different states. So in each and every state, there'll be a different power consumption. So mostly when we use any IoT application, basically we collect the data from the different sensors and we do transmit them wireless, right? So when we collect the data, the chip has to be active, and during the other times the chip has to be in a deep sleep state, right? Or basically it shouldn't consume that much power. That means it has to be kept in as low power state as possible. So generally shutting down the chip is not preferable in many cases. Basically we keep it in deep sleep state where RAM details could be retained, or RAM could be off as well. So one of the states which is predominantly used is deep sleep state, and SiWG917 has that particular deep sleep state. So, now if we compare some of the deep sleep specifications, deep sleep current specifications of different chips that are available in the market, one of the biggest competitor in terms of price to SiWG917 is ESP32, which is from Espressif, right? Espressif, if you see their particular datasheet, they claim the deep sleep current to be around 10 microamps, whereas SiWG917 has a deep sleep current claimed from the datasheet as 2.5 microamps. And if you see the Nordic chip NRF7002, which is a Wi-Fi plus Bluetooth combo, it mentions a deep sleep of 15 microamps. So while these are the deep sleep currents which are considered from their datasheet values, please do check their in practical terms to see if these particular deep sleep currents are met or not. But one thing is definitely sure, SiWG917 has a far better deep sleep current, which is one of the most important factor in selecting this particular chipset.